So the next feature I want to talk is lane keep system and or lane departure warning. Now this should be pretty easy to understand because we already talk about the driver alert system, and this is a similar logic. Basically, the front windshield camera looks after the lane lines, and it looks after the geometry of the lane. And if the vehicle is crossing over or is about to cross over a lane, then there is a warning on the cluster showing that, hey, the vehicle is now about to cross or about to drift out of the lane. But this warning will not go off all the time. For example, let's say the driver actually wants to go on the next lane and puts the turn indicator, like left turn indicator, and in those cases, the lane keep system will disable itself and it won't give the warning. But let's say if the driver is just driving and for some reason got distracted and started going over the lane lines, in those cases, there will be a warning. And different OEMs have different approaches for this warning. Some OEMs will send out a message on the cluster. Some will also give a steering feedback. So there will be a small amount of vibration on the steering to alert the driver that, hey, you are crossing the lane lines. And in some modern cars, we also have a power steering control module, which will give a correction torque to the steering. That means if the car is actually drifting, then the steering will try to turn it automatically and trying to bring it back to the bounds of the lanes. This system can also be combined with the blind spot system because the blind spot is already detecting the target vehicles from the blind spot area. And let's say if there is a target vehicle, then and the driver is trying to cross the lane. In those cases, also both the system will work together and give out a warning that don't cross right now because there is a blind spot target detected, and also you are over the lane lines. So different features can be combined into different functionalities together. So coming to the boundary diagram, again, pretty simple, similar to driver alert system. There is the environment, which is the lane markers typically. The front vision system camera detects the lane markers, and the side corner radars are of course used for the blind spot logic. Both the information goes into a signal processing algorithm, and there and those information is again going into the blind spot logic or the lane change warning logic. So all the combination of decisions is made in the lane change warning manager, and depending on the type of event, if the driver is only about to cross a lane marker, then a different warning will go out. And if the driver has already started to cross, then some kind of steering feedback is also uh, transmitted. So all the feedback is transmitted through the CAN output in the form of cluster graphics or the power steering control module. And from the driver input side of things, there is of course the vehicle CAN model. Vehicle CAN model is giving all sorts of information on the size of the vehicle, the speed of the vehicle, and all those things are taken into account by before calculating the warning type. And then there's a turn switch logic. So if the turn switch is activated, then there will be no warning at all. But if it's not activated, then there will be the cluster graphics. So again, there are due to the improvement of sensors, these features have become very robust and can be combined with other features like adaptive cruise control and to create level 3 autonomous systems. So moving forward to the next features, automated parking. Automated parking is a whole another segment of features. There are many different types of features out there, but mostly they are related to parking. There are two types of feature. First is the level 1 feature, which is very less automation, which is typically the visual guidance. and that is achieved by the rear view cameras. So when the car is in reverse gear, the rear view camera will activate, and there are different types of HMI to show or help the driver better estimate the reverse conditions, such as these green lines and the steering output. So that is a level 1 feature. But when it comes to level 2, we have some more partial automation there. And what it does is it uses the ultrasonic sensors. Ultrasonic sensors are surrounded around the car, and they transmit the sonar waves to create a map around the car. By map, I mean all the sensor inputs are used to determine the different environments, or kind of like a boundary around the vehicle. And this condition, which we are seeing on the vehicle, on the image, is a typical parallel parking scenario. Parallel parking is nothing but parking a car parallelly between two uh, vehicles. And all this is achieved autonomously by using the ultrasonic sensors. So first, the ultrasonic sensors use the signals to map a surrounding. And once the surrounding is mapped, a path is planned. So a steering path is based on the gap between the vehicles. A path is planned, and the steering output is given automatically to the driver, and the car can autonomously park between the two vehicles. It is a very interesting feature, and there are different OEMs do it very differently. For example, some OEMs can completely autonomously park, while some OEMs only give steering input, and the driver is still responsible to give the throttle input. But there are different modifications on this feature right now. Typically, there are three types of systems which are working closed loop. First is the ADAS controller. Second is the steering controller, and third is the powertrain or brakes. As I said, not all OEMs involve the powertrain component, but there are typically three or four ECUs which are in closed loop. So looking at the boundary diagram again, your environment is again the different conditions of the different vehicles around the car. So the ultrasonic sensors and the rear view camera are the critical sensors. The ultrasonic sensors are used to create the map around the vehicle, and the rear view camera is used to measure the distance between the two vehicles, or the host vehicle and the target vehicle. Both these information goes to the signal processing system. Signal processing system then goes to state estimator. Now, what does state estimator do? State estimator is determines on different attributes, such as the distance of the vehicle, the type of vehicle, and how far the different two vehicles are. And based on the map construction and the state estimator, there is a path is planned, and basically in the path planning, all the calculations regarding the steering angle, the throttle output, and how much steering angle should be given to achieve. All those things are calculated. And finally, those signals go to the vehicle CAN. And the vehicle CAN depends on the scenario, gives the corresponding outputs. So first output is, of course, the graphics. You will be able to see it on the screen or with the camera, 360 camera view on how the car is performing. And there will be inputs to the power steering module based on how much steering angle left or right is supposed to happen. Third will be the powertrain control module. This is again a two-way approach. Sometimes in some systems, the ADAS controller will give the input to the powertrain, or sometimes the driver will have to give the control to the powertrain. And finally, there is the brake controls. Suppose the suppose there is another target behind the vehicle, then the brakes will be applied to avoid any kind of collision. And this is the overall closed loop system. From the driver's side, of course, the driver settings are the critical input. The driver has to choose whether or not he wants to park. there is typically a parking button on the steering wheel, not on the steering wheel, but like on the central panel of the cluster. And once they select that, the car will try to determine a suitable steering spot and then try to park. So very useful feature, very important feature also, because then there are many accidents which happen while parking. Those accidents are typically not fatalities. However, they can cause pretty severe damage to the vehicle body and can cost the customer a lot of money. Then the final feature is something I want to talk about is traffic sign recognition. And this is again, I feel, a very useful feature. And this feature is self-explanatory. The front camera or the vision system uses the computer vision technology to read the traffic sign speed limits around the road. And once that is determined, those inputs are given to the driver or the cluster. And this feature is mostly a convenience feature because the driver is now able to tell what's the speed limit of the vehicle or speed limit of the road they're driving in. But the more interesting use of this system is with adaptive cruise control. So some systems, like in Ford system, there is a feature called intelligent adaptive cruise control, where the ACC looks at this information, the speed limit information, and automatically adjusts the set speed of the vehicle. So let's say you're driving on a road where the speed limit was previously 100 kilometers per hour, and it changed to 120 kilometers per hour. So the traffic sign recognition will detect the speed limit, and it will update the adaptive cruise control set speed automatically. So this is again very useful for drivers, especially in countries like Europe, where there are very strict laws for overspeeding. And also, this is one of the features which Euro NCAP has mandated from model year 2022. Quickly going over the traffic sign recognition boundary diagram, the main sensor is the front windshield camera. Some systems or some OEMs also use navigation information. Navigation information is typically the GPS. If you use Google Maps often, then you might have seen that the GPS navigation also have the speed limit information. So it uses both the type of information, the camera detection and the navigation information. And both information goes into a arbitration logic, um, where the logic is used to determine what speed limit is correct, which speed limit to be shown to the driver. And once that computer vision arbitration is achieved, it goes to the TSR logic. The TSR logic typically has two jobs. First job is to, of course, display the correct graphics in the cluster. And second job is to send that output to any other features like adaptive cruise control or any other feature which might be using that information. From a HMI point of view, the driver settings, of course, the drivers can choose if whether or not they want a certain feature to be enabled. But the cluster inputs, the cluster graphics will show a different type of speed limits. There will be a speed limit on, and there can be a supplementary speed limit. Let's say no passing sign. So this means this road does not allow any kind of overtaking. So all those type of signs like school zones or hospital zones, those can also be displayed to the driver. So this feature overall improves the driving experience, and helps the driver to make better decisions while driving the car by maintaining the lawful speed limits. So that was mostly the end of all the features which I want to talk about. Hopefully by now you have got a fairly good idea on what kind of sensor sets and how are used, and the kind of interface which happens between the different ECUs in the vehicle and with the driver and the environment. And to briefly touch upon the future scope of ADAS features, if you remember in the beginning, I was talking about the SA level of automation. Currently, most features are at level 2 automation, and every OEM is currently trying to achieve level 3, level 4, and so on. And it's not going to happen overnight, but the key is over the years, these ADAS systems will be self-sufficient to fuel the technology for fully autonomous level 5 vehicles. And that is what most of these companies are trying to do. One of the most popular systems in the world is the Tesla Autopilot system. The Tesla Autopilot system is basically adaptive cruise control combined with lane centering, combined with any kind of object detection like BLIS or PCA. So all these three, four features are coming together, working together to help the car drive on its own for at least a certain amount of time. Not only Tesla, but different OEMs like Ford and GM have their own versions of this technology. Ford likes to call it Copilot 360, GM calls it Super Cruise mode. But the one common thing in all these technologies is they are still under level 2 category because the government regulations still don't allow them to deploy on all the roads. These features are only activated on certain road conditions, typically like highways or freeways where or expressways where the road conditions are very good and most of the people are following the law and following the speed limits. So these systems can work much better than in an environment where the vehicle environment and the structure is very robust. But of course, with coming years, we will see more and more capabilities from these technologies. For example, Tesla has already deployed assisted lane change, which is basically a feature which helps autonomously change the lanes between the lane lines. And the foundation of all those features is, of course, the features which we discussed today. All these, when you combine three or four different features together, you have a level 3 autonomous system. Some of the upcoming technologies which is currently very in heavy demand is V2X. V2X means vehicle to infrastructure communication with 5G technology and more improved internet technology. The vehicles will be able to communicate with the infrastructure or vehicle to vehicle. What does How does this help? This helps because let's say there is a traffic accident 2 kilometers on the highway which you are driving in, and the infrastructure will automatically tell the driver that there is an accident ahead. So that way, the car and the driver can prepare well ahead to slow down and avoid any kind of further accidents. There are several cases, especially in countries like China and India, because of the level of pollution and smog. There are several accidents on highways, and it's typically because the vision systems of the driver and the vehicle are compromised due to the smog and different environment conditions. And so in those scenarios, V2X technology will be very useful to priorly alert the driver about any kind of collision or threats. Some of the other technologies are neural net driving, which is basically a more machine learning based uh, driving experience. There is currently a lot of research still pending in this area, but most of the OEMs are still working on it. And the third is LiDARs. As I mentioned before, LiDARs are currently very expensive. They are very good sensors, very accurate sensors, but they are very expensive for mass production and they are very delicate to damage. So over the course of time, I'm sure these sensors will be less expensive and more robust for day-to-day cars. So I wanted to discuss a little bit about how to make a profession in ADAS. And by now you must have figured out like ADAS systems have really complex features with different and very varied sets of technologies coming together and working. Almost every field of engineering, whether you are a mechanical engineer, electrical, computer science, you will have some kind of role to develop in any kind of ADAS system. I want to touch upon some of these typical areas which most OEMs are focusing on when they look for talent in in this area. Those are like control systems, vehicle dynamics, model-based system engineering, software architecture, computer vision, and all sorts of artificial intelligence like deep learning, machine learning, neural net learning. Functional safety. Functional safety is typically not an engineering level field, but it is very important because functional safety are engineers are responsible to define the safety requirements of these features. As you can tell, most of these features need to be very well designed and very safely designed because they are at the end handling the customer's life and the passenger's life in their system. So functional safety plays a very crucial role in this ADAS field and any sort of automotive background at the end, because most companies are still very new to these technologies. So if someone has an experience in the automotive world uh, by working with different suppliers and working with the components of the vehicle, they can surely find a good fit in any form of ADAS job. The right hand side, I'm showing you, and I'm sure most of you must have seen it at some point of your education or college career. So this is the typical systems engineering V approach. System Since ADAS systems are mostly electronic systems, so we follow a typical systems engineering approach. And the reason I'm showing you this is every component of this system engineering step will have some kind of ADAS related responsibilities which you can focus on, starting from management and planning. This is where the design or concept of a ADAS system is developed. Concept of operations is where different type of algorithms, different type of sensors, what sensors are we going to use, all those decisions are made. System level requirements, and this is where functional safety guys and different engineers come into play, where they define the capabilities of the system, they test the limits of your sensor, they test the limits of your vehicle and define the requirements on how well or how well this ADAS system is going to work on a condition. Then there are subsystem level requirements, of course, since we have different components like powertrain, braking control, steering control. We need to define separate requirements for every powertrain, every vehicle ECU. Detailed component design. This is typically your CAN signal interface or the software architecture. Uh, Most of the companies use model-based systems engineering approach, which means they use tools like Skill-Lync, MATLAB, Modelica, or ADAMS-CAR. So these are some of the softwares which are used to design the vehicle dynamics and the logics behind these systems. Finally, there is hardware and software implementation. And this is where electrical engineers or electronics engineers have a very crucial role. They go on to implement the software into the actual hardware. And finally, there is the component verification and subsystem or system level verification. So this is where different backgrounds of engineers, mechanical engineers, electrical engineers come into play. They test the system to their extreme limits, make sure they are robust and ready for public roads, and they try to see if all the requirements which were defined on the left side are still being followed during the integration and testing phase. And finally, once the system is validated, they are commissioned and they are put into production. So this is a very generic systems engineering approach, but what I'm trying to say is ADAS systems have many different stages of development, and there are many jobs and many roles and responsibilities overall in the entire development process to find a career. Finally, we have come to the last slide. So this is some of the, it's a very detailed map of different companies and different technologies which are involved in ADAS. Typically, we have the top level or tier, the OEMs, most of the OEMs like the car manufacturers or the technology manufacturers like Google, Uber, Apple. So they come into the autonomous category. And then there are different suppliers, tier one and tier two suppliers. There are processing suppliers, which give you the hardware and the processing capabilities. There are sensor manufacturers, all the cameras, radars, ultrasonics, different type of sensors are developed. There are connectivity manufacturers, connectivity, for example, the 5G technology, the internet connectivity, vehicle to vehicle, vehicle to infrastructure technologies. These are developed by some of these companies. There is mapping, and so as I mentioned before, a lot of navigation and sensor mapping is involved. So mapping companies are better suited for developing the maps and navigation facilities. There are core algorithm developers. As you can see, Mobileye. Mobileye is one of the leading computer vision technology companies. They are almost the industry best for any sort of front camera related technology. And of course, these are very complex systems, embedded systems, so you need to have a very strong cybersecurity and functional safety. Because of the nature of the system, they can be easily hackable. So cybersecurity plays a very important role in making sure that these systems are non-hackable and they cannot be tampered in any form of way. And of course, for all these processes, you have different companies which develop different tools. For example, MATLAB, Vector, DSpace. These companies are developing the tools and capabilities which are further used to develop some of these technologies. That was my last slide. That was the end of my presentation. Hopefully, you were able to get some good information out of this.